Hello everyone. Today we have lesson 14, estimating instantaneous rate of change. So last time we went over the average speed, average rate of change, and instantaneous rate of change, right? So instantaneous speed means at the moment about the speed, right? Okay, so let's revisit colors and history from El Cerrito to San Francisco State University. The equation is f of x that models the distance colors traveled in miles, where x is time. So this is distance, right? And the x is the time in hour. Okay, we do evaluate f of 0.5. So let's do it. So f of 0.5 means this means x, right? So we substitute 0.5 into the x. So there will be negative 104.5 to the third power plus 141.5 to the second power minus 4.9 times 0.5. Okay, so we calculate exponent first. So negative 104.5 to the third power, which is 0.125 plus 141.5 squared, which is 0.25. Now we calculate 4.9 times 0.5, which is 2.45, equal to, we calculated this one, we have negative 13. The next term is 35.25. And then the last one is 2.45. Then we get 19.8 miles. Okay, so what are the unit for f of 0.5? So we talk about this is a distance, right? So distance in miles. And then x is in time, in hour, right? So this is miles. Moreover, we can say that miles per hour, right? Okay. What this mean? F of 0.5. Okay, so we have f of 0.5 equal to 19.8. So 0.5 means 1/2 hour. It's hours. That means 30 minutes, right? Minute. So we can say that 30 minutes into history, Carlos had traveled a total distance of 19.8 miles. Okay. So let's the next one. So we have, how can we figure out Carlos's instantaneous speed at exactly 0.5 hours into his trip? Okay, now we have average speed. So how did we find average speed last time? So we had like a slope, right? So think slope. So slope is m equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But we had a function notation, so exactly same as, right? So we are using b minus a, then f of b minus f of a, right? Okay, now we knew from the algebra course, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is change in y over change in x, right? Change in y over change in x. Okay, let's take a look here. Average speed. So change in distance over change in time, right? That's what we did the last time. Okay, now let's compute. Let's compute average speed over a tiny time interval. Okay, so we had a change in distance when 0.5, right? So let's denote it this way. F of, let me write down this one first. Copy and paste. Oh, I cannot. Okay, so that will be distance. We will change that f of 0.5 plus tiny a little bit minus f of 0.5 or over and 0.5 plus tiny a little bit minus 0.5. Okay, so we knew this is miles per hours, right? Okay, let's calculate this one. So we have f of 0.5 plus tiny a little bit. That means let's give us 0.5001. 0.5001. Okay, then we substitute into this function. Copy here. Okay, so there will be negative 104. We have 0.5001 to the third power plus 141 and 0.5001 to the second power. Oops. Minus negative 4.9 and 0.500001. Okay, if we calculate, I showed you how to calculate, right? But you can use decimals. So there will be everything. So 19.805.8058. I said 8058. Yeah, this is miles. Okay, then we had earlier f of 0.5, right? So f of 0.5, 19.8 miles. Copy, please, copy. Let me copy. Huh. Oh my gosh, no patience for that. Come on. Come on. Hello. Cannot do it. Okay, never mind. You win. Oh, f of, let me write that. Okay. F of 0.5 was 19.8. So let's do it. How about from here, right? So here, oh, how about that? Yeah. So we have I just found, right? So 19.8058 and f over 0.5 was 19.8 over, and then if we calculate the 0.5001 minus 0.5, okay, now we calculate numerator, we have 0.00580985 over the denominator has 0.0001, which is 98.1 miles per hour, right? Okay. So the idea is like this. So we had earlier the 0.5 plus tiny or a little bit, right? So let's denote note. We said 0.5 plus tiny a little bit. So 0.5 plus h. H can be tiny a little bit, right? So in that case, we give it to the 0.001 because we had 0.5001, right? So then h equal to 0.001, right? That's a very tiny a little bit, right? Okay, now look, we had, oh, the number is not right, huh? 0.0001 then, yes? Because we had 0001, yeah? So 000. Okay, now can you see that we are using h there, right? Tiny a little bit. And then looking at the denominator has 0.0001, right? Okay, now we are using 0.5 plus h there. And then this is h as well, right? So here is the idea. This is what exactly we're using it, right? And then I told you we had 0.5, think earlier, right? From the example, because not always the same. So we have 0.5001 minus 0.5 equal to 0.0001, right? So that was the H, right? And the H was 0.0001 as well. So H is agreed, right? Okay, now, why we are doing this one? We take the limit. So this, this notation is a limit. Okay, we read when h approach to approach to 0, when h approaches 0, the limit of, and then we read f of 0.5 plus h minus f of 0.5 over h. Yeah. Okay. So this one was average, right? We had average speed. So average speed was change in distance, change in time. Now we had exactly the same as average distance, right? So this is average distance. Oh, did I say average distance? Average speed, right? Okay, but then we take the limit, then that will be instantaneous speed, right? So we want to know about the speed at the moment, right? So we take the limit. It's okay? Now, we have different terminology. So we called everything this one derivative of the function. So let's take a look. Derivative of the function at any value x, we denote like little things there, right? Then let's take a look, right? So this is what we did earlier, instantaneous speed. That is the derivative of f of x. So this one we read f prime of x. Can you see that? We have a little thing on the top, right? Okay, now if this limit exists, so limit exists means we get the number. The answer is number. Okay, then they said if f prime of c exists, we say that the function is differentiable at c. So it's a terminology. If this limit exists, if f prime of c exists, then we say that f is differentiable at c. Okay? All right. Now, so the first question was, how can we figure out Carlos's instantaneous speed at exactly 0.5 hours into history, right? So how we did, we make average speed, means that make a change in distance over change in time. So we had average distance, right? Sorry, keep saying the average distance, average speed, right? In average speed, we take the limit when h approaches to 0, right? Then that's instantaneous speed. And then we give us the notation f prime of x, yeah? So that is instantaneous speed. Okay, so this is the one, exactly 0.5. Then we had 58.1 miles per hour, yeah? Okay, now, all right, so now, how could we find Carlos's speed at exactly 3 or 4 hours, 45 minutes into history? Okay, so 45 minutes divided by 60 minutes, we get 0.75. So they said exactly, right? So at the moment, right? So we want to find instantaneous speed at the moment, right? So means look for instantaneous speed. Okay, so let's denote f prime of 0.75 equal to, so let's make h equal to 0.0001 still, okay? So let h equal to 0.0001. So we have f of 0.75 plus 0.0001, very tiny a little bit, minus f of 0.75 all over 0.75 plus 0.0001 minus 0.75, right? Okay. We needed the function. Yeah. The function is, I'm not sure I can, oops, I can copy this one. Copy. Okay, good. I copy, but then can I erase this one? Oh, good. I can erase that. All right. So let's calculate f of 0.750001, right? Equal to -104 and 0.75001 to the third power plus 141.75001 to the second power minus 4.9.75001. Okay? All right, let's calculate. Okay, I realized that I made a mistake there, right? So 0.75 plus 0.0001. So 20 and then 01. So missing the omit 10, right? And this one too. And this one too. And the last one. Right? Okay, so I calculated. So there will be 31.7656. Okay, let's do this one for copy it. Okay, 75 here. 75. $75. $75. Okay, so there will be 31.7625. So we have this one will be 31.7656 minus 31.7625 over and 0.0001. So we have this one 31.0907 miles per hour, right? Okay, let's move on. All right, so example, use tiny value for h equal to 0.0001 to find f prime of 1 and f prime of 7 for, okay, so f prime of 1 equal to f of 1 plus 0.0001 minus f of 1 or over 1 plus 0.0001 minus 1, right? Okay, that will be 1.0001 into the function. So let me do this one first. Over 0.0001, right? So there will be 1.0001 to the second power minus 1 squared over 0.0001, right? If we calculate this one, 1.00020001 minus 1 all over 0.0001. So that will be 2.0001. So we can say that 2.0. Okay, how about this one? This is for A. This is for B. This is straight. Okay, for B. So f prime, oh, we did not do f prime over 7 here. So I'm going to leave it for you. Please do that. So f prime over 1. So f of 1 plus 0.0001 minus f of 1 all over 1 plus 0.0001 minus 1. So that will be f of 1.0001 minus f of 1 all over 0.0001, right? Okay, so the function is x cubed, so 1.0001 to the third power minus 1 to the third over 0.0001. So if we calculate, this is a 3. All right. Okay. So first try f prime over 7. So let me just give you answer then. 14.0001 in here. 147. F prime over 7 equal to 147. Same process, okay? Okay, let's do this one. Suppose the monthly profit of car dealership is P of X 500 minus X squared minus 100, where X is the number of cars sold, is the tiny value of H equal to 0.0001 to find instantaneous rate of change of profit when 200 cars are sold. Explain the meaning. And 300 cars are sold. Explain the meaning. Okay. Oh, this is the last one. Okay, so we have instantaneous rate of change. What this mean? This means we need to find the derivative, right? So means derivative of the function. Okay, so the first one, A, 200 cars. So P prime of 200 equal to P of 200 plus 0.0001 minus P of 200 or over 200 plus 0.0001 minus 200, right? Okay. Equal to, let's denote Let's find out this one first. Copy. So P of 2, that is 200.0001, right? Equal to 500. 200.0001 minus 200.0001 squared minus 100. Okay, so that would be, if we calculate this one, we get 500, oh, no. 59,000 and 900.01. Okay, what about the P of 200? So let's do it. Copy. So we have 200, right? 200. Hundred. Okay, so we get this one 59,900. All right, so then this will be 59,900.01 minus 59,900 all over 0.0001. Okay, so there will be 0.01 over 0.0001, which is 100. So unit is $100 per car sold, right? So dollars per car. Okay, so explain the meaning. So at a sales level of 200 cars, they sold cars 200. And this is a profit function, right? So profit will increase by approximately $100 if one additional car is sold. Okay. Second part, 300. So 300. And then I need a function. let me just copy everything. Yeah. Okay. $300. $300. Almost done. So 300, right? So 300 and 300, 300, 300, 300, 300, 300, 300, 300, 300, right? Okay. So we get 300. So 59,899.99. And this is 59,900. Okay, so that will be, we want to calculate this one. That will be 59,899.99 minus 59,900 all over 0.0001, right? So that would be negative 0.01 or over 0.0001. Okay, so we get, this one is negative 100 and dollars per car, right? Since there's no space, dollars per car, right? Okay, they say that the last sentence said that use a prime notation in your answer. So this will be P prime over 200, right? So we have P prime over 300, which is negative $100 per car, right? Okay, so what this means? This means when they sell 300 cars, the profit decrease $100 if one additional car is sold, right? Okay, so at a sales level of 300 cars, profit will decrease by about 100 if one additional car is sold. Okay, so in that case, if they sell the 300 cars, profit decreased by $100. They're losing money, right? So seems like they have two different types of cars. So this car, if they sell 200, then they get profit $100 if one additional car is sold, right? This one, another car types, and if they sell 300 cars, then losing money. Make sense? Okay, thank you for watching. See you. Bye.